How's everybody doing out there? AP Calculus. Hey! How's everybody doing today? It's a beautiful day to do a little math problem, or more than one math problem, to prepare you, yes you, the calculus student for the AP Calculus exam, which is in how many days? 80 days! Hey, I like the little shadowing on there, that 8 and 9. We got some pretty high-tech graphic artists back there. So let's just get right here. We already have a caller. What's that phone number on there for people who want to call in? 89 days. What's the phone number? 925-3123. We got a call from Jaguar. Molina. Who is this?
Xochitl.
Xochitl! Xochitl, what'd you do in class today?
E to the U.
E to the U? Okay. Well, we're going to give you a... Well, let's see Xochitl for a second here. Hey, Xochitl! You got a really nice smile. You got really good teeth.
Ooh, thank you.
My teeth are crooked a little bit. Hey, are you nervous?
A little bit.
A little bit? Okay, well, I'm a little nervous too, so we'll be all right here.
Okay.
Hey, we're going to start. You did E to the U today? We're going to review that for a second, okay?
Okay.
Hey, if f of x is e to the x squared, what's f prime of x equal to?
E to the x squared times 2x.
Hey, that was too easy. Times 2x?
Uh-huh.
That was way too easy. Okay, we got bump it up a little bit. Bump up and divide, baby. Bump it up and divide. Wait, hold on, I'm running that problem. How can you answer the question?
Bump it up and divide. Okay.
When do you bump it up and divide?
When we integrate.
When you integrate, right? Okay. Hey, real quickly here, let's do these two problems here. If f of x is equal to natural log of x squared and g of x is equal to natural log of x squared, I want you to find the two derivatives, f prime and g prime of x, all right?
Okay. Okay. F prime is 2 quantity natural log of x and times 1 over x.
Times 1 over x. That's awesome. Okay, and what's g prime of x equal to?
2x over x squared.
Over x squared, which is 2 over x. Hey, Xochitl, that's awesome. Hey, I got a question for you. Which one of these, f or g, is also equal to 2 natural log of x? Which one, f or g?
G.
It's g, right? And if you would have set that equal to that and taken the derivative, what's the derivative of 2 natural log of x?
2x.
2 times 1 over x, right? It's the same answer as before, right? Hey, Xochitl. Hey, that was pretty good.
Okay.
All right. All right, call in again, all right? All right. Hello? Courtney?
Yes.
Hold on. Wait, we got the Marcus in the other room for you from Skyline. That's what I heard. I don't know. He wanted to know. There's Courtney!
Hey, move the camera back some.
What's that? Yeah, it's a great picture.
Thank you.
Okay. Hey, hey, move back from the TV a little bit.
Okay.
I got an integral problem for you here, okay?
Okay.
Miss Harmon tells me you're like a super integrating stud.
Oh yeah.
I don't know if you've ever seen this one before.
No, I haven't. But I can do this.
You can? Okay. How do you do it?
Well, okay. Well, what I'm going to do first is. Hold on, I'm thinking.
What are you going to say? Hey, when you integrate, if it looks a little weird, what's the first thing you got to think about doing?
Okay, well, I'm going to say d of x over x divided by the natural log of x.
Okay. Okay, and then so what are you going to do about that? When you integrate? What do you want to do? When you integrate and have
U prime over U.
I'm trying to get the U prime over U.
Excellent. You're trying to find u, right? So what is u going to be?
The natural log of x.
U is equal natural log of x. And if u is equal natural log of x, what's du equal to?
1 over x dx.
Right, it's 1 over x dx. So therefore, excellent.
I know.
Do you know Miss Harmon's boss, Susie Oliphant, is here in the studio today?
Really? Your boss is here, Miss Harmon.
And she's everybody's. She's my boss too. Everybody's boss.
Oh.
So what was I forgot what I was going to say. So if you got this is u and this is du, what is this gonna look like?
Well, it's gonna look like the natural log of the quantity of the natural log of x.
Right, because this right here is just du divided by u.
Right.
This part is du and this is u. So what's the integral of du over u?
The natural log of u.
Natural log, right, of the absolute value of u plus c. So the answer is natural log of x plus c, right?
Oh yeah, that's it.
Hey, that's a fine job. You know, I used to have a bell around here. You know, it got a.
That's not a bell.
I know. Thank you very much. I knew that. I appreciate that.
No problem.
I'm going to tell DeMarcus that you made fun of me. So, all right. Hey, great job, Courtney.
Okay.
Drew.
Good afternoon, Mr. Fleischer.
What's going on?
Not much. Just sitting here watching your great show.
You are?
Yeah. Hey, will you tell Miss Arthur hi? She's not here.
Hi, Miss Arthur from Drew. And what's that? You feel left out that she's always with Brian Adams?
Yeah,
that's not nice, Drew. You shouldn't say that.
She doesn't like Hillcrest. She didn't take our class's picture.
Hey, this was for Courtney. Got the bell back. Hey, Drew, what type of problem you want? What are you doing in class?
Well, I don't like what we're doing in class right now.
Well,
so
how
about we do something that I was good at in class?
Okay, well, we're going to give you a very hard problem, okay? Because this is a really hard problem.
Okay.
This is like last week classified as very hard.
Is it like the serial number off $1?
Okay, he's messing with me. I'm a calculus teacher here, messing with me here. Figure represents an observer at point A watching balloon me as it rises from point C.
Okay.
The balloon is rising at a constant rate of 3 meters per second.
Okay.
And the observer is 100 meters from point C.
Okay.
Okay, now here, find the rate of change of the area of the triangle. What are we trying to find in terms of calculus terms?
Not relating to the balloon?
Well, in terms of calculus
it's a related
symbols.
rate, isn't it?
Yes, in calculus symbols.
The derivative of the y, the change in y.
Well, we're trying to find the change of the area.
Change in the area of the triangle.
So we're gonna try to find dA dt, right?
The change in area over the change in time.
Right. That we're trying to find the rate that the area is changing. Now, in order to find dA dt, what do you have to write an equation for?
We have to write an equation for the area of the triangle.
Excellent. Awesome. Great job.
Thank you.
So what is the area equal to?
Area of a triangle is 1/2 base times the height.
Is this Drew Wagner or Drew Davenport?
This is Drew Davenport, Mr.
Okay.
Fleischer.
All right. Just want to make sure there. 1/2 times the base times the height, which is just equal to 50y. The area is equal to 50y, right?
That's right, because 1/2 times 100 is 50.
Hey, you know what? The man can multiply. That's awesome.
right.
So
I'm proud of it.
If A is equal to 50y, Drew, this is great.
We're doing good.
We're doing well. Better than that. We're doing well.
Okay, that's even better. Okay.
If A is equal to 50y, what's dA dt equal to?
It'd be 50y over.
Try again.
Let's see. The change dA over it'd be 50.
50 times
50 times the dt.
d what dt?
dA dt.
dy dt.
dy dt.
Whenever you take the derivative, Drew, like if you take the derivative like 10x squared, if you take the derivative with respect to t, this is 20. You do the derivative thing, 20x, and you always do d blank dt, like that.
D blank.
Whatever the variable is.
Okay, so it'd be dA or dy. dA.
Right, it's like, here, hold on, Drew, hold up for a second. See, if the derivative of a is 1, And so it's like 1 times d/a dt.
Okay.
The derivative, you're doing the same thing on both sides of the equation, just like algebra. 50y, it's 50 times dy dt.
Okay, 50 times dy over, that makes sense.
And what is dy dt equal to?
It'd be, well, it's going up at 3 meters per second.
Right,
So
y is changing at,
At
3
3.
meters. Right, so the
Should be
answer is,
3, or,
it's 3.
yeah, that's right.
So it's 150. What are the units?
150, can you scoot it over a little bit? Meters squared.
Very good. Excellent.
Per second.
That's great. Hey,
And I
dude,
don't even have anyone helping me.
I know, that's a really good, that's pretty impressive.
Okay.
When you take the derivative with those related rates, just do the d blank dt. Okay?
I'll remember that d blank dt.
You got it. I'm going to give it to you next time.
All right, take
good
care.
luck. All right, you too. Miguel!
Hey.
Miguel, what's your last name?
Hello?
Now, what's it? Are you with, is this Miguel Contreras?
Yes.
Now, I got a picture with you and Xochitl here,
Yeah.
you know, and it's, I don't know, this is a family show here. And you know what Ms. Brzezinski wrote on the back?
Oh, okay. There's nothing wrong.
Nothing wrong with that. We're cool, right? Hey, what type of problem you want? Give me, what type of problem you want?
Nah, pretty medium or an easy one.
A pretty medium, there are no ones. Hey, let's do this one here. Let's go to, if f of x equals x times square root of 1 minus 2x quantity cubed, write an equation for the line tangent of f at x equals 1. If we got to write an equation in the line tangent, what 2 things do we need?
You need a point and slope.
Very excellent, Miguel. A point and a slope. Good job. So what do we have? What are we given?
The x equals 1.
So we're given like half a point. How do we find the other half?
You put the 1 into the function.
Excellent. Man, there is no stopping Miguel, except by Xochitl. Plug in 1.
1 times 1 minus 2 times 1. 1 minus 2 times 1.
So it's 1.
Yeah, it's okay.
So what's 1 times negative 1 cubed?
Negative 1.
Excellent. So, and how do you find, we need the slope, right? That's another word for slope.
You gotta get the derivative.
Derivative! Slope derivative! Every time you hear the word slope, it's like, when you see a green light, you automatically try to, you go. You know what I mean?
Yeah.
It's like when you hear the word slope, what do you think of?
Oh, the derivative.
No, say it loud and with emotion.
The derivative.
Yeah, okay, that's a little weak attempt, but we'll take it.
Alright, to get the derivative down, you gotta do the product group.
Alright.
That's first, and just derivative of the second.
What's the derivative of the second?
3 quantity 1 minus 2x to second. Times negative 2.
Excellent.
Okay,
Okay.
Plus the second.
Man, this looks plus the second.
Yeah. Times the derivative of the first.
What's the derivative
which is
first?
1.
Okay. And then you just plug in 1 here to get the slope, right?
Yeah.
So it's 1 times 3 times negative 2 is negative 6 plus negative 1. So the slope is negative 7, I think. And so from there, it's pretty easy, right?
Yeah.
Hey, that's, and so let me finish it. It's y plus 1.
Y plus 1 equals negative 7. X equals x plus 1.
Right. Hey, Miguel.
Minus,
Miguel, that's a fine job, Miguel.
All right.
I think we got to bump it up and divide next time, all right?
Okay, yeah.
Okay, good job.
That's cool. All right, thanks.
Justin?
Yeah.
Justin, what's your last name?
Lowry.
Justin Lowry?
Yep.
Man, what are you doing? Are you in BC?
Yep.
We got a fine picture of you. What about those stars, man?
What about them?
They looked pretty bad last night, didn't they?
Yeah, they're kind of falling.
It's Justin Lowry! Hey, we need some applause here.
Well, there's nobody here.
It's you and Mr. Morrow?
No, there's a few people here.
I know. Hey, what type of problem you want?
I don't really know. Whatever you want to give me.
Whatever I want to give you. Hey, what'd you get on AB last year?
5.
I know, it's pretty hard. You're putting pressure on me here. I'm an old guy here making, a guy gets already a 5 on AB exam. I got to think of a problem off the cuff here. So let's see how good you are with this.
Great.
What are you going to do? That's probably too easy. I got a harder problem if you call in next time.
Alright, is that e to the 2x over 1 plus e to the what? What is that?
It's e to the 2x also.
Okay.
I'm going to give you another problem here in a second.
You want me to work this one?
Well, yeah, I know, but tell me the first thing to do here.
Well, this looks like a natural log problem.
Okay, you're done. I'm going to give you a different problem. That was too easy. Okay. I thought that might be too easy for you. That was pretty good.
Can you zoom in a little bit on that?
Yeah, I sure will. We got to get those magnified. Okay, this is a little bit harder problem. If h of x is equal to f of x plus 2, if the integral from 1 to 4 f of x dx is equal to 5, what's the integral from 1 to 4 of h of x dx? There's two ways to do this problem, and that's why it's a good problem.
Well, we have a relation between h of x and f of x.
Right?
So, if we know what the integral of f of x is, we can use it to solve for h of x.
Okay, and so what do you want me to do?
You can subtract the 2 from both sides.
Subtract the 2 from both sides.
Well,
okay, well, I mean, I don't know if that's right. I'm trying to think. What does he say?
no, okay, so if we have the integral of f of x, we just plug it in. It would
Okay,
be...
well, you say, okay, well, what do you want me to plug? Tell me what to do. I mean, it's a hard problem. And, you know, there is a national TV audience watching.
Oh, yeah. You would add the integral, so it would be 5 plus the integral of 2 dx from 1 to 4.
Say that one more time.
It would be the integral of 2 with respect to x from 1 to 4 plus 2.
Oh, so what you're doing, I mean, I think this is what you're doing. You're doing, the integral of h of x is just this. Now, are you going to, did you separate it out like that? Did you go the integral, separate this, the integral of 1 to 4 of f of x dx plus the integral of
Right.
1 to 4 of 2? Did you do that?
Yeah.
Okay, and you know that this is 5 and this is easy. This is 2x from 1 to 4, which is 8 minus 2. It's 6, right?
Right.
So the answer is 11.
11.
Hey, you know, want to see a cooler way? I mean, that's a great way to do it. Want to see another way you can do it is visually from 1 to 4, if the area is 5, whatever that is. If you know h is just shifted up exactly 2, then if it's shifted up exactly 2, then it would look like this. And so you know that this area, which was shifted up 2, you know this part was 5, and this part would be a rectangle 3 times 2.
Yeah.
And that's our cool?
Yeah.
Hey, Justin,
Yeah.
fine job.
Thanks.
All right, call in again.
I definitely will.
All right, thanks. Jared Olds!
Hey,
Hey, you know, I got your driver's license this time. I had your
ID, school ID.
This time I got your license.
No, it's
I'm just kidding. I can't have your license. Hey, what'd you do in class today?
we reviewed for a test over natural logs and some trapezoidal stuff like that.
What'd you get last semester, grade-wise? A, B, or C?
B.
Got B. Okay, here you go. You ready? I want you to see.
I wanted to Riemann sum.
Yeah, Riemann sum. I'll give you a Riemann sum. Tell Miss Arthur, no Riemann sum for you. I want just for that. You have to do these 3 problems.
Okay.
Actually, you know what? We'll make it easy. Do we have someone else waiting on the phone, Homer? Okay. What we'll do then is you get to pick, because you are the great Jared Olds, brother of the very passive Brandon Olds.
Yeah, right.
He was not. I remember one time he couldn't watch the show because he got a fight in the parking lot. But the true story. See, Miss Arthur's confirming. You get to pick any one of these problems
Okay.
because you are Jared Olds. The girls at WT White are screaming right now.
Oh, okay. I want the second one.
The second one. Okay, what do you do? What do you do, Jared Olds? What do you do?
Okay, you find.
No help from PA over there. Okay.
you find u.
And what's u equal to?
U equals square root of 1 plus x. 1 plus x squared.
Okay.
And you derive that. du equals 2x dx.
Excellent.
Okay, and you have an x on top, so you need to put a 2 up there on the equation.
Okay.
So you want it to equal du.
So what do you got?
You have 1/2 on the outside.
You have 1/2 to make it right.
Yes, to even
I
it
know
out.
some teachers teach it differently. I don't want to confuse them. You're the only ones left. That's right. du over square root of u. Du over square root of u. How do you do that? What the heck do you do there?
U to the same thing as negative 1/2.
Hey, excellent job.
It's on bottom. And
Yeah, it's really great. So what do you do there?
then you integrate it, bump it up and divide.
Bump it up and divide, baby.
Yeah. And then you can sub in the value for u.
Right, and then it cancels out, and then it's
Yes.
plus c, and then you got u to 1/2, which is square root of u, or square root of 1 plus x squared plus c. Hey, Jared, that's a good job.
All right, thanks.
Hey, fine job, Mr. Olds. Fine
Okay.
job. Call in again. Who's out there? Allison.
Yeah, from WTY.
Now, is this the real Allison, or
Well, of course.
now? Oh, wait a minute. This is Allison. Not
Allison, yeah.
and not okay. Because
Oh,
now,
because
did you talk for Alicia last week?
No.
Someone did.
No.
Okay.
Yeah.
Allison, how do you pronounce your last name?
Playsted.
Plaisted?
Playsted. Uh-huh.
Plaisted.
Mm-hmm.
That's Allison Plaisted. Woo! All right.
That's me.
Do you know, last year, who was that, Miss Harmon? That that nice guy wanted to go out. But we had a dating service on this between WT and Brian Adams, and but the girl at Brian Adams was like my daughter, not really my daughter, but so I had to like put the guy through the ringer. Anyway, it's a long story, but what type of hey you have a test tomorrow coming up?
Monday. Yeah.
Monday.
Mm-hmm.
Hey, did you know that problem that I gave Justin Lowry?
Oh, yeah.
You knew how to do that?
Yeah.
Well, let's see you do it then.
Oh, well, wait a minute.
That's simple enough.
I guess. Okay. Okay, let's see. Okay, what we have to do, I'm going to talk in my language.
You know what?
Okay.
Take your time, relax. What's the first thing you got to do when you integrate? What do you have to do?
Well, you have to... Well, okay, I guess you could talk like in U and DU language.
Hey, I know Miss Harmon probably already told you this because I know you just went through this today. But you know how you know? It's like, how do you know when to set u equal to 2x? Well, if there's only one e, like if there's only one e in the integral, then you set u equal to the exponent, the argument. If like a problem like this, there's only one e in there, so you're going to set u
Right.
equal to that.
Right.
If there's more than one e in there, you're not going to set u equal to the exponent.
Right.
That's a little, but you already knew that, so there
Of
you go.
course.
Okay. Well, then, so what do you set equal to u?
Okay, so U is going to equal to 2x.
U is equal to, I just said no!
What?
It's the big one. Ever see Sanford and Son?
No.
Okay, never mind.
Okay, so U is going to be at the bottom. U is your bottom
U is my
denominator.
bottom.
So it's 1 plus e to the 2x.
Right, and because, okay, seriously, Allison, you only set u equal, with the e guys, you only set u equal to the exponent if there's only one e. But see, I see two e's.
Right, so we have to use the bottom. Okay, I see.
Or you have to use something else, you just don't use the exponent.
Right.
Okay, so if u is equal 1 plus e to 2x, what's du equal to?
It's equal to 2e to the 2x.
Okay, and then so what does this become?
So that becomes, you have to put 1/2 in front to balance up.
Excellent. 1/2.
And then integral, and then 2e, wait, no. Okay, 2e to the 2x
Okay.
over 1 plus e to the 2x power dx.
Okay.
Is that right?
Well, yeah, but how do we put it in terms of u and du?
Oh,
Okay, that's it. Okay. Then I'm just gonna put 2 du
Okay.
over u.
Well, it's really.
Oh, actually, yeah, you could just put 1/2 and then just put u du over u.
Okay, here, let's see this right here. The numerator up here is 1. This is d. If you multiply du times 1/2, you get this.
Right.
1/2 times du, you get this, and this is the bottom.
Right.
So it matches up perfectly. Like if you substitute this back in, it'll look exactly like that.
Okay.
All right. So and what's the integral of 1/2 of du over u?
Okay, so it's 1/2 of, I don't know.
Integral of du over u. Yes, you do, Allison. No pressure. No pressure.
Yeah, well, I'm feeling a lot.
Hey, Allison.
Yeah.
I'll sing to you.
Okay.
Allison, oh Allison. That's pretty bad. Okay, let's go back. 1/2 of du over u.
Yeah. Okay, so it's gonna be 1/2
Uh-huh.
the natural log
Okay.
of u.
Okay.
Yeah, plus c.
So
Okay,
1/2.
so it's gonna be natural log of 1 plus e to the 2x.
Okay, here's a hard question.
see.
I'm not letting you off the hook yet. Hey, why don't I need absolute values here?
Because it'll never be negative.
Hey, that's pretty good. That was pretty impressive. That was really good.
Oh,
That.
thank you.
Well, no, thank you.
Thank you.
No, thank you. Okay. Call in again, all right? Bye, Allison.
Hello.
Hello?
Okay. How you doing?
How you doing? How you doing? Who is this?
Ronnie.
Lonnie?
No, Ronnie. I'm sorry,
Is
Ronnie.
this Ronnie Allen?
Yeah.
Oh, Ronnie. Is Miss Bradford there?
Yeah. You want to say hi?
You know what Miss Bradford did today?
What?
Miss Bradford called me to specifically point out something I did wrong. Was that nice?
Ain't she so nice?
I know.
She's
Did she
so
ever,
nice.
Did she ever do that to you?
She's cool.
Did she ever do that to you?
Nah, she's nice.
I know. She's very nice.
She
I
brings
know.
food and all that, and
I know. That I tell you, that
It
food.
feeds
That
us.
food is. Hey, what'd you say? That's Ronnie.
okay, scary picture.
Ronnie.
Scary pictures.
Scary pictures. Hey, Ronnie.
Yeah,
Okay.
I'm here.
Okay.
I'm here.
Hey, I'm gonna give you a. I remember you. You're pretty smart.
Oh yeah, I'm the one with the straight hundreds in her car.
Okay, I gotta give you
I
a.
won't play it.
Hey, what type of problem do you want, Ronnie?
In
Too late. You have to-
any, I don't care. Doesn't matter.
A big problem. It's a big problem.
Limit.
Big problem. Big problem.
Limit. Those limits. Oh yeah. Okay.
Oh yeah.
Okay. This is just to me. Okay. This is just. I can. Okay. You're basically taking the derivative of 1 over x squared. Basically.
Hey, Ronnie, that is really impressive.
That's all you need to know.
That's right. You know, but that is really. You know what that shows? That shows you are a calculus student.
Yeah.
Let's take the derivative of that. How do you do that?
It's power rule, which is x to the negative 2, and then which is subtract 1, which is to the negative, negative 2 all over x to the over the little
Over what?
2
Over
negative
what?
2 over the
Over what?
No, to the negative 3 to the negative, which
Okay.
goes down to the bottom.
Okay,
Goes
so
to the-
it's negative 2 over x cubed, right?
Yeah, that's what I was trying to say.
Hey, Ronnie, that's a fine job, Ronnie. Okay?
Yeah.
All right, fine job. We hear someone.
Huh?
That's super, okay? Make sure you call in again, okay?
Cool.
Jaguar.
SPM.
Is this Myra?
Yeah, this is me.
How you doing?
All
Now,
right.
is this Myra Gonzalez?
Yep.
Now, how many pictures Ms. Brzezinski going to give me of you?
2.
I got like 17 pictures of you.
She's a model!
No.
Look at this.
Too pornographic.
Hey, you guys got some fancy locks at look at that. What, I mean, it's pretty impressive.
Patent lockers.
Myra, what type of problem do you want? I mean, like you could pick either like difficulty level or topic level, or what do you want?
Give me a difficulty level. Medium.
A medium?
Yeah.
Okay, medium. Here we go, medium. So what's Ms. Brzezinski serving out there today?
4 gourmet ice creams.
Gourmet ice cream. Gourmet ice cream. I want that. I want that.
Yeah.
We got
Just-
moose dropping.
Hey, what's a good estimate of this? Let me give you multiple choice here because I don't like this question without multiple choice.
Okay, what was the question?
The graph of f is shown below. What is a good estimate of the integral from 1 to 6 of f of x dx?
It's 12.
Well, how do you know that?
I'm smart.
I know you are, but I mean, that's not right. How do you know that so quickly? Why is that?
Because it's rectangle.
Right, because what does this say in English? What
The
is it?
area under the curve.
Excellent. In English, boy, I'll tell you, that's those Jaguars, man. I'll tell you.
I know.
And in English, it means the area underneath the curve. And like it's a squiggly line, but you know what? It sort of looks like it's close to a rectangle that's 6 times 2, right?
Mhm.
That's a fine job. You know what you get?
What?
You get the bell.
Wow, Belle.
I missed
Hey.
it the first time. Hey, Myra, send more pictures. Okay, we don't have enough. Okay, we don't have enough. We need more.
Okay.
Hey, call it again. Great job.
Uh-huh.
Oh my God. Is this Emily Smith?
Yeah.
Oh my God. I got.
Oh my God.
Emery, turn the TV down a little bit.
All right.
And I can't joke with you because you get mean.
I get mean.
Well, is that your brother? No, I always get confused. Where's your brother in college this year?
He's at McGill in Montreal.
He's at Yale in Montreal.
McGill.
One more time.
McGill.
Oh, okay. I didn't hear you, but I pretend I did. Hey, Emery,
Yeah.
it's a fine-looking picture there. What's up? Can you hear me okay?
Yeah, there's a kind of...
Kind of an echo?
Yeah.
Hey, can you, okay, well, let's give it a shot here. Let me give you this one problem here, okay? Okay, here you go.
Nice. Read that. Is it continuous at x equals 1? Yes, it's continuous.
Why?
Because they both approach 1.
Well, just because they both approach 1, does that mean it's... What happens if I gave you this problem? Is this continuous at x equals 1?
No,
Why not?
because there's x less than and x greater than. It's not.
Right, so it's got to both approach it and it's got to be defined at that point. Excellent. Okay, is it differentiable at 1?
Yeah,
Why?
because it is.
Because it is.
Yeah, you
Because-
take the derivative and it's differentiable.
Well, what's the derivative?
2x.
2x for x less than 1, and what else? It's 2 for x greater than or equal 1. So at x equals 1, the slope from the left and slope from the right are both 2. So therefore, it is differentiable. Emery, it's pretty hard to hear you, but that was a fine job. You got that high-tech phone over there at SEM, don't you?
Yeah, I do. Actually, yeah, high tech.
Fine
Yeah,
job, Emery.
I need to give some shout out to.
Okay, I really can't hear you, but tell your mom and brother I say hi. Who's out there?
This is Bill Massey of the W2 White Longhorns. Oh, yeah. Ow! Hook 'em.
Now, who is this, Matthew?
Bill Massey.
Oh, Bill Massey, Mary Ellen's brother.
Yes.
How you doing?
I was doing better before I was named that, but
Do you have red hair like your sister?
no.
You don't?
No, she's the only one in the family with red hair.
Really?
Yeah.
That's interesting. Okay. Do you know that actually red hair, you have to have genes from your mother and from your father's side? I hope I'm right. If Miss Lee or any other biology teachers are, yeah, is that right? Are
Yeah,
you,
that's a recessive trait, so yeah, you need it,
Oh.
the gene from both parents.
Mr. Porter tell you that?
Yes.
Wow. Tell him. So how could you be the only one in the family?
I guess they both had the trait somewhere in them.
Okay. Or, you know, okay. Anyway,
Yeah, we're not going to go there.
Hey, Bill. PG, not PG-13, PG, okay?
Okay.
Hey, what type of problem do you want? You want something to help you review for your test?
Sure.
Okay, I better think of something quick then.
Well, doesn't e to the natural log just cancel itself out and leave x to the third as the function?
Okay, that was too easy. So,
And so that's 3x squared.
okay, let me think of another problem here. It's a lot harder. All right.
I'm not the one laughing, they are.
That's real nice. Make fun of the guy. Make fun of the guy under pressure. Okay.
You or me?
All right, here you go. Ha. Oh, wait a minute. Forget this.
Oh, well, thanks.
Hey, what's the thing that I told Allison? What's the key if there's only one E? Every time.
Make the exponent u.
That's right. You don't even have to think. If there's one E, 98.324% of the time, you set u equal to the exponent. And then what's du equal to? What's the derivative of square root of x?
That would be 1/2 x to the negative 1/2.
Excellent. Which is equal to 1
1 over 2 square root of x.
Okay, so what is this equal? Excuse me. What is this equal to? And why don't you give your picture to Miss Harmon?
Well, I just did at the beginning of this class session, so you'll have it by next week.
Okay.
Okay, so that'd be
What is the top equal to?
okay, so it's e to the u over u.
It's e.
I mean e. So we have e to the u.
Take your time.
Over du.
Over du?
If you have the 2 out in front of the integral sign.
Okay. Let me ask you something. If du, okay, let's take a look at this. This is our problem. E to the square root of x over this.
Yeah.
I'm going to rewrite the problem as like this.
Yeah. Time.
Okay? This is e to the u. What is this equal to? If our du
That is 1/2 of du.
it's what?
No, it's 2 times du.
Right, so it's just e to the u times 2 du, right?
Yeah.
Hey, I know, if you had more time, I mean, you're like, 40 seconds on TV, you got to figure this out. But the key is when you have one e, actually the key is right here. The key is, it's so bad, pathetic. If you have one e that you set u equal to the exponent, and it almost always works out. So what's the integral of e to the u du?
That e to the u?
Right, it's just 2 e to the u plus c,
Plus c.
which is 2 e to the square root of x. And that's it. Pretty easy, right?
Sure.
Set u equal to that exponent if there's one e and it works. It's pretty cool.
Absolutely.
All right. Hey, no, thank you, Bill.
Thank you.
Bye.
Bye.
Scott!
Hey, Mr. Fly,
Hey, what's your last name?
Vasquez.
Scott Vasquez?
Yeah. No, Guillermo Vasquez. I called last week, remember?
I know. Why'd you say your name was Scott?
I didn't.
Scott was too chicken to get on.
Scott was, oh, well, yeah.
Turn it down.
You know, Miss Arthur always has to, like, chime in a little bit there. We love Miss Arthur. It was her birthday last week.
Turn it down.
It was her birthday. She was 28. Okay.
What? Whose birthday is this week?
Miss Arthur, did you get your tape?
Yes, I did Homer message.
Did you hear that, Homer? Okay. Hey, Homer? Who's Homer? I'm talking to myself! Hey, Guillermo?
Yeah.
Okay, here's a hard problem, but I hear you're really smart.
Well, you're right.
It's okay. Now, hey, tell Miss Arthur that you want no help. There's no pressure. You want if you want help, you want to get from the other Bryan Adams students. Right?
Okay.
Okay. Okay, what's another word for slope?
derivative.
Hey, I don't know if you guys know how to do this yet. Yeah, I think you do. Okay, you do now. So this is like the derivative. Hey, you have to write an equation in line tangent at x equals 1. Okay? If you have to write an equation in line tangent, what two things do you need, Guillermo?
You need a point and you need a slope.
Okay, we got a half a point. How do we get the point?
Plug it in the equation.
Well, we don't have an equation. We just have the slope.
Oh, it's 4. It's up there.
Yeah, it sure is. So you got the point 1, 4.
Right.
Well, how do we find the slope at 1? That's Arthur, you're not allowed to talk.
That was Jerry.
Well, the slope, it says the slope is given by 3x squared plus 1. So you just
Right.
plug in the
Excellent.
numbers.
Right, so you just plug in, and now you plug in. Oh, we got to plug in 1 and 1. Is that what we do?
No, 1 and 4.
Ah, 1 and 4. That's awesome. 4, 8, so it's 1/2. Hey, that wasn't so bad. That looked like a hard problem. You know, this was off a free response on the AP exam, like somewhere around 98 or 99, somewhere around there. So it's y minus 4 is equal 1/2 times x minus 1, right?
Right.
Hey, Guillermo.
Hi, Ed.
Fine job, Guillermo. Fine job.
Thank you.
Tell Scott if he doesn't call in, he gets no date from WTY.
That's down.
All right.
All right. Thanks
See
for
ya.
playing.
Thank you, Mr. Vasquez. Hey, Tommy,
Yeah?
are you guys? What phone are you using?
My phone? Myself?
You're using. Are any chance you have a phone in the room?
Yeah, we do.
Well, it's probably next time better to use that one.
Alright, thanks.
Okay, next time. But hold on. Hey, what's your last name?
Lou?
Your last name?
Lou, L-U-U?
Oh, Tommy Lou.
Yeah.
I thought you said your name was Luke Stone.
No.
It's like what? Okay, yeah. The rules are we don't. No more cell phones.
Alright. I'm sorry. There's someone using in here.
Tommy Lou. Hey, Tommy.
Yeah?
That's how do you get the hair to stand up like that?
Just some good gel.
Some good gel.
Yeah.
Okay. That's fine. Pick a problem, pick a topic, pick something. Help me out.
Something easy.
Something easy?
Yeah.
I hear you're smart though.
No, you didn't have that.
I heard. That's what I heard.
From who? Not in Bedford.
Here you go. Try this one.
Alright. Yeah, I can't read that.
Hey, Tommy.
Yeah. Yeah, what's the answer? KB minus KA.
What's that?
KB minus KA.
Well, how do you know that? What's the integral of K?
Integral K is constant, so you just take the X. Yeah, just use power rule or whatever.
It's just Kx from A to B, right?
Yeah.
So it's KB minus Ka, right?
Yeah.
That wasn't too bad, right?
Yes, that's easy.
It's easy. You want a harder one?
No, that's alright.
Oh, wait, hold on for a second. Here, it's too easy. Here, let me give you a helper out here. Here, try this one.
Uh-huh.
Try this one. One more.
Can't read that.
Okay, hey, it's actually getting 2 hours to hear you. Tommy, call back on the regular school phone, okay?
Alright.
All right.
Alright.
Hello? Hello?
Hello?
Jaguars?
Yes?
Hey, who am I talking to?
Rosara.
Shamika?
No! Rosara.
Rosario? Okay, I'll find you, Rosario. I think you're at the end of the pile here.
Yeah, probably.
But I got you with Miguel. I thought that he was Xochitl.
No, not Miguel.
No, that's what I got you with. I mean, does Xochitl know about that?
No, it's somebody else.
No.
Sit down.
Actually, I got you with Reyes and Bendrick. I got you Reyes with Bendrick and a stuffed animal.
Vampire.
that?
I want to suck your dog.
Hey, that's a fine-looking picture. Hey, is Bendrick there? I remember.
No, he's not here.
Okay, he's a fine math student. I remember him. The
Ooh, right?
Okay, how do you do this?
For
Plus 3.
Okay, first of all, if I
first we have to take the derivative.
okay, take the derivative. Now this ain't gonna be easy here, so let's do our
It's the
best.
quotient rule, so it's going to be a plus x quantity
Mm-hmm.
times 6
Mm-hmm.
minus 6x times 1
Times 1. Okay, we'll just leave it then. And
over a plus x squared quantity.
Okay.
Yeah.
Excellent. So what do we do now?
Now you plug in 0 into the x.
Well, let's simplify. We could do that. You're right, and I don't mean to. But let's just simplify the top. How can we
Okay.
simplify the top?
Distribute
Distribute. Excellent, Rosar. Excellent.
6a plus 6x minus 6x over a plus x squared.
Which is equal to
6a over a plus x squared.
Okay, now what do we do? So that's the derivative. And,
Now you plug in the 0 into the x.
and what do we do with the 3?
Put it on the other side equals.
Excellent.
equal to
Excellent.
3.
Excellent. Good. 6a over a squared. What do we do now?
Now you cancel one of the a's on top. The
What? How do you get so smart?
practice.
What? Practice. That's right. I like that answer. Practice. Okay. So what? 6 divided by what is 3?
2.
Yeah. Excellent. Fine job, Rosar. You get
Thank
a bell there. That's awesome.
Just shut your shit.
What's that?
Oh, nothing.
Is that better?
Somebody's too excited here with ice cream.
Hey, gourmet ice cream, not just ice cream. Gourmet.
Gourmet.
Gourmet ice cream. Try to say
Okay.
that fast. Hey, call in again, okay?
All right, thanks.
Bye.
Hello?
Austin.
Yeah, it's Austin Ross from WTY.
Awesome, Austin.
Austin Ross.
Hey, do you remember? I remember you. You
Yeah,
remember me?
from the PSAT
That's
program.
right. Yeah, when you were a freshman.
Yeah, like 2 years ago.
Yeah, I think it was. No, you're a senior now, aren't you?
Junior.
Wow. That's
Oh yeah, Bill wants to get the hookup with one of the Bryan Adams girls.
I bet you do. I bet you do.
No, Bill does. I got a girlfriend.
Yeah, that's not what I heard. Okay. All right.
Right.
You know, that's the only reason why we have a show. Hey, Austin.
Yeah?
What's happening? What type of problem do you want?
I don't know, what kind of problem should I do?
Impossible.
An impossible one.
Are you really smart? I remember you were really smart. Okay.
Yeah, Miss Harmon said you'd have my PSAT scores memorized.
That's what I'm trying to remember. I do. I remember you're really smart. Okay, here you go. I'm not going to give you an impossible one, but I'm going to give you a very hard one.
Okay.
Okay, I don't want to scare. Well, this is a very hard one. This is very hard. How much time do we have left? Because this may take.
We got a good 10 minutes. I'm fine.
All right, here we go. Strap your boots up, boy.
Let's see.
If you want a little help, a little inspiration, it's Alicia! Come on, Austin, you can do it. You can do it.
I'll make sure and tell her she cheered me on.
Oh, Lisa.
Go. Okay.
Let's see. Y equals. Or tangent to each other at 0.10. Okay, so you know, first of all, that the derivatives are going to be equal at 10.
Very good. Okay, that's real good. So we'll skip.
And you know if they're tangent, the values are also going to be equal at 0. So you're going to take the derivatives of both,
Hey, wow, you really are smart.
and then
Okay, so wait. We take the two derivatives,
yeah,
and then
you can set them equal.
we set them equal. But what do we do first?
We need to plug in 1 for x.
Right, because we know that whatever's going on at 1, 0, wherever the curves are, we know the tangents are equal. X
Yeah.
equals 1. So we got 2 plus A is equal C minus 2. Well, it helps us out a little bit, I think. So we got C minus A is equal to 4, something like that.
Yeah. And then we also know that the values of the functions are going to be equal
Wow, awesome.
to 0 at that point. So.
Awesome, Austin. Awesome, Austin Ross. Okay, that was really good. That is really good. That is really good. So if you plug in 1,
Yeah, you plug in C.
so you got 0 is
Okay,
equal.
you're gonna plug in. You're gonna take each original equation and plug in the point with the value 1,
Yeah,
0.
I'm doing it for you. You told me what to do.
Okay.
So we got C is equal to 1.
And then you're just gonna do some substitution.
We got C is equal to 1. We got A plus B is equal to -1. Do we have everything we need to know to find? Okay, when we know C is equal to 1, so we know C is equal to 1, we can figure out A, right?
Yeah.
What's A? 1 minus what is -4?
-3.
Yeah, it might be easier if you actually write it out. That means to put pressure on you. So you got A, move the A, subtract the 4. A is -3. Okay, A is equal to -3.
You plug that in to
And
there.
then B is equal to 2. Hey, Austin,
Yeah.
you know, that was really a hard problem. That was it's considered a very hard problem. You know what? Austin,
Yeah.
you know what you get? You get a bell.
Woo! Better than that clapper. All right, I got both.
You know what? I'll tell you. Yeah, that was pretty good. I didn't, some people, Miss Brzezinski. Okay. Hey, Austin, that really is very good, all right? Excellent job, okay? And we'll hook Bill up. If you get the impossible problem right next time, we'll try to hook Bill up, okay? It's
Okay.
on your shoulder. All right, call in again. Good job.
Okay, bye.
Bye.
Hello.
Hello? Hello?
Hello. Sorry about that.
Oh, that's okay. Did you hear that feedback, too?
Yeah.
Okay. So, okay. Well, I didn't know. I never know what people hear. But I always hear you, Miss Arthur. I always hear you. I hear you in my dreams, Miss Arthur.
Which goes Bill?
What type of problem do you want? I think we need to move away from the TV just a little bit.
What problem do I want?
What type of problem do you want?
Just any.
Any problem, okay? Any problem. Here you go. Any problem.
Oh. Okay. You assign. What? Am I kidding?
What do you do?
Okay. You assign U to be x squared.
Excellent. Excellent. U equals x squared. You know, I don't know why I keep on giving these integral problems because Miss Arthur teaches it differently, but I mean, you do great. You're doing great.
2x dx.
2x dx. That's awesome. Okay, what do you do now?
So you multiply 1/2.
Very good. Thank you for saying that. Instead of putting the 2 up top. So 1/2 times sine of u du, right?
Yeah.
What's the integral of sine of u?
Negative sine. Cosine.
Positive or negative?
Negative cosine.
Positive or negative? Positive or negative?
Negative.
Yeah, I know. I'm just seeing if you're strong with your conviction. So you got negative 1/2 cosine of x squared plus c, right?
Yeah.
That's pretty easy. That wasn't so bad, right?
Right.
Okay. Were you nervous?
No.
Hey, do we have another caller? Hold on, stay on the line. Do we have another caller? Oh, we got another caller, so we have to say bye.
All right.
I'm
Bye.
sorry. Bye. Marlon.
Hey, how you doing?
Hey, how are you doing?
I'm doing fine.
Oh, is this Marlon Hodge?
Yes,
How
sir.
you doing, man? You're from New York. How
I'm
you
doing fine.
Okay. Marlon, are you on the? I think there's Marlon, the great Marlon Hodge. Yay!
Not a good picture.
Well, it's just a little fuzzy. It's a fine picture. You know, it doesn't show how fine looking you actually are.
Yeah.
But I am married, so I'm not no funny business. Hey, Marlon.
Give me a medium-sized problem.
Medium-sized problem, you got it. Okay. Here we go. Well, we got about 2 minutes, so we got to... Here we go. F of x equals cosine x over x prime f prime x prime f prime pi by 2 over no calculator.
All right, differentiate that. All right. Hold on, let me think. First, you differentiate cosine. Hold on.
It's a quotient rule, right?
It's a question. Oh, okay. So the top going to be x times sine of x.
Positive or negative?
Negative.
Right. So it's x times negative sine of x.
Minus cosine x 1.
Right. All
We have to
over.
put it x squared.
Okay, that's good enough. And you know, on the AP exam, you do not have to simplify it.
Okay.
Isn't that great?
That's great.
Okay,
Then
now,
you
but
just
if I
plug
wanted to
in-
find f prime pi over 2 no calculator, what do I have to do?
All right. So it'll be a power of 2 for x on the outside.
Excellent, excellent.
And then that's sine of 90, so that'll be 0. No,
Be what?
negative 1.
Negative 1, okay.
Okay.
What's
And-
cosine of 90?
0.
Okay. All over?
Pi 2 squared.
Okay, how do I simplify this? How do I simplify this,
First, you're
Marlon?
going to take out a pi 2 at the top and the bottom. Well,
I want you to do it where there's only one fraction bar.
okay.
What's the answer if there's only one fraction bar?
Well, what I would do is just, first I'll take a pi of 2 and then I'll flip the bottom.
Okay, so right, so just negative 1 over pi over 2.
Mm-hmm. So it'll be 2 pi times negative 1.
Excellent.
2
So
over pi times negative 1.
the great M.H.
Yeah.
Marlon Hodge, ladies and gentlemen. It's a
Yeah.
fine job, Marlon, fine job.
See you later.
Hey, see you later. Thanks
I'll
for
see you
calling.
next week.
All right, you
Or
got
whenever
it.
I call in.
Okay, you call in.
My whole class say, hey. Miss Bradford say, hey, too.
Tell Miss Bradford I say hey.
Oh, she said no more cell phones.
No more cell phones. All right, thanks a lot. Hey,
See you later.
listen, all right, call in again next week. Y'all have a safe and happy calculus studying weekend, and we'll see you next Thursday. Bye.
Tricky second, жить weird first, говорить normal second, and читать normal first conjugation verb. Хорошо. And of course, as usual, you need to go ahead and practice the vocabulary that was in the lesson, and practice those dialogues. Simplify them. Okay, you may not want to talk about Anton Budionov and Sasha Demidov. You may talk about John Brown and Jane Smith. Я не знаю. Do what you want with those things. Хорошо? Practice. Okay? Vocabulary, conjugations. Thank you very much. До свидания.